but they're not opposite sides. Because you look at the y's, they would be easier to kill. Yeah, two reasons they're opposite sides, and the numbers are easier to work with.
But I mean, so what you did was fine, but you didn't need to. Here you would need to do something because none of them are already. So now that you've got that, you plug it back in either one. So you get the other part, you get what X is. Cool, I like it. Yeah, it looks like. And then for this one, like which one? So if you do it right now, nothing cancels. So if only that was what? It would cancel. Only that was. Yeah, so I would do this whole thing if they got to. So this would be 100.
Oh.
But, so what you did wasn't wrong, it was just more than you had to, because do you see how in the beginning, these would cancel? You didn't have to multiply by anything, they already want to cancel. Yeah. But you look at the right answer, that would be 100, and then you can divide that by 25, so it doesn't come out gross. So now you know what y is, you can plug it into either one of these to figure out what x is. Yeah, you can do either one because they have to be the same then. You're finding where they're the same, so that's why it doesn't matter which one you pick.
Okay.
Yeah, okay. Oh, you forgot to do 2 times 12. Yeah. All right. Let's try this out. So, several of you that I went around, you were asking for help, you were multiplying this first one by something. But what you want to do is you want to first step back and say, would anything already die if I added them together? Yeah, the x's would go away, right? So you don't have to multiply by anything. The only reason I ever have to multiply one or both is if there's something that doesn't already match. So if I add these together, what happens?
5y. Yeah.
So those go away. 5y equals
20.
20. So y is
4.
4.
I will plug 4 up to.
And now I can use this in either one of these. I'm going to use the second one. Why not? Negative 5x plus twice y equals 3. You guys cool with this so far? So once I know y, I can plug it into either one. I can plug it into both. And they better come out the same or else I made a mistake somewhere. So you get negative 5x plus 8 equals 3. Subtract 8. Negative 5x equals negative 5. So x is 1. So the answer is 1, 4. Cool. Maybe. So if I did graph those lines, which I would really not want to do, because they have gross y-intercepts, for example, but if I did graph them, they would meet at 1, 4. So what about number 2? Will anything die if I just add them together? No. Now watch. Now, this is not what we're going to do, and hopefully it's not what you necessarily did. But if I did want the x's to die, if I just had a thing about x's, y isn't cool with x's, I want to kill them. What would I have to do to make the x's die? X's. Multiply this by, if I multiply this by 5, I've got to multiply this one by negative 3, because they aren't different signs. Now, some of you guys are like, what the hell are you doing, Jeff? And like I said at the beginning of that, that's not what we would do. Hopefully you could be more clever than that. Why would I mess with the x's when the y's are almost the same already? Which one needs some help, like you said? Good, the top one. Multiply the first one by 2. So if I multiply this guy by 2, so the first equation becomes 6x plus 4y equals 24. Good. So again, a few of you guys are leaving that as 12. You've got to do the same thing to both sides. And the second one I'm going to leave alone because it's already got a minus 4y here. So when I add those together, now I've created it so that when I add them together, what happens?
You kill the y.
Kill the y's, I like it.
Then you left the x. Was 22.
So then x equals?
X2.
X is 2.
So the x.
And then I could plug that in. Which one?
The
I don't
first
care.
one. First one.
Okay, the last one. So if I put it into 5 times x minus 4y is supposed to be negative 2. 10 minus 4y is negative 2. Subtract the 10. Negative 4y is negative 12. Divided by negative 4. I'm going quickly because you all should be able to do all that. Y equals 3. So once I know one of the variables, I can plug it back in. The whole problem with this is I don't know shit. I don't know either one of these variables. The minute I know one, I can plug it in wherever the hell it is. I can put it in there. So I just pick one because that's all I need. So again, the answer here would be 2, 3. Kick ass. X first, Y second. All right, how do we feel about that? Is that all right? All right. Let's do one more. That all looks young. So that's number 5 on page 67. Yeah, you can kill either one you want to. Now the one I'm going to do is this one though. Yeah. But I mean, on this one you could either, but you'd have to multiply if you want to kill the x's.
Yeah, I think I framework of it.
If you multiply this by 5, you have to multiply this by negative 3, so it would be opposite sides. Yeah.
We're going to get rid of the x's and now we're moving by negative 4 by negative 2. Would it cancel it out? Or will this cancel out?
So you multiply by negative 2.
Yeah.
All right, so then this will be negative 6x.
Yeah.
And this will be negative times negative is. Yeah.
And that's 3.2 negative 2. No, 42.
Positive, yeah. Okay. Cool. Alright, so let me catch up to you guys. Some of you guys might have killed the y, and not a bad idea because they're already different signs, right? But the x's would need smaller numbers. You see those trade-off? So I'm going to go ahead and kill the x's to just show you how it looks if you have to multiply something by negative. You don't multiply them both by negative because then you end up with the same problem, right? So if I take the first one and then multiply by what to kill the x's?
2.
2. If I multiply by 2, 6x minus 8y equals negative 44. I must multiply this one by negative 3.
Okay.
Because I want these to be opposite signs here, right? So negative 3 times 2x is negative 6x. Negative 3 times 5y is negative 15y. Negative 3 times 16 is negative 48. So if I multiply them by 2 and 3, then the 6x's would be the same sign. They would not cancel when I add them together. That's all there's to it. You just want to make sure that the same number but different signs. So what do I get when I add these together? Yeah, negative 23y. Don't be joking me like that. 92 negative. So thankfully, 23, well, let's see, does it go into 92? How many times? 4 times, cool. So y is 4. So if you did it the other way, how many guys killed a y? Anybody killed a y? Killed a y. Did you get y is 4? Is that so far the same thing? All right. So let's kill the x people. We're on the right track. We got y is 4. How do you get x? Plug it in. So if I use this guy just because it's there, 2x plus 5 times y, but y is 4. 2x plus 20. Subtract the 20, you get negative 4. You end up with negative 2. Cool. So what you guys got?
Yeah.
I like it. Just say yes. Yes. I got that way long time ago. I've been waiting for you, man. So negative 2, 4 would be the answer. Kick ass. Yes, ma'am.
So if you were to get rid of the x or the y, the answer would come out the same?
Exactly. It's got to. It's just either you kill the y and then you substitute what you get for x back in, or you kill the x and you substitute what you get back in for y. But you're just getting one number before the other one. They're both the same number, right? So there is an answer that exists. So either I'm going to get the 4 first, like we did, or I'm going to get the negative 2 first, like some of you guys did. So it doesn't matter. That's why it doesn't matter. They have to be the same no matter which way you do it. I like it. Woo. Oh yeah, sure. Yeah, it should still work, but this will be 23. Yeah, it should still work. Yeah. All right. Cool. So let's get into the next level of stuff. So to do that, I want to remind you guys something that will seem silly at first. I'm going to overanalyze a very easy problem, just to make sense of what we're about to do. This is section 4.4. So remind me how to graph. How do I graph that? How do I graph that? So first, yeah, I love it. I love it. Somebody like, well, first Jeff would make a line. All right, so I got my line. You got like 2, 3, 4, right? So that line has all the real numbers on it, right? Yes, sir.
You put a solid dot, like on where the 3 is.
All right, we used to, but we sort of will again. Yeah, so I would put a bracket, right? But it used to be a solid dot, sure. Right? And then Jeff had to go and mess everything up. A math guy, so we do that. And then, of course, I faced it that way because which way do I want to shade? Up. Now, let me overanalyze this to death. Another way to figure out which way to shade is to plug like 4 in. is 4 bigger than or equal to 3? Yes, it's bigger than 3, right? So it is bigger than or equal to 3. So that's why I shaded on that side. When I plug a 2 in, what do I get? 2. Is 2 greater than or equal to 3? No. So what I've done, I'm overanalyzing this to death, but just hang with me. I've divided the line in half using a point. The point is 3. On one side of that are all the answers. On the other side of that are all the not answers, right? Good and evil. Or just answers and not answers. So when I have a plane, or, here's a plane. There's a piece of a plane, right? That's a piece of a plane. Not a, but a plane. Of course, you could make it a plane, but we're not going to. How would I cut that in half? What would I use to cut it in half? Would a point cut it in half? Yeah, if I had a sword and I chopped it through, that would be a line that would chop that bad boy in half. Are you with me? So that's how I cut it in half, and I say, here's the answers to the non-answers. To cut this in half, I need a line, and then I can shade one side or the other. It's the same idea, it's just now that I'm in 2 dimensions, I've got all these other ways I can go. So it's not just going to be one line of shading, it's going to be a whole area of shading. So what the hell is that going to look like? So what if I had this? So first thing to do is, and what was the first thing we did here? We plotted the point 3. So either with a bracket or a dot, we plotted the point 3, and then we figured out which side to shade. So here the first thing to do is to plot the line, and then figure out which side to shade. So how do I plot this line? What do I know about this line?
We start at 3. And go up 1.
All right, start at 3, because the y-intercept is 3, and then you go up 1, over 1, or down 1, back 1. Either way I go.
That's solid.
I like it. So some of you guys are ahead of me. Since it's allowed to equal that line, I can include all the points on that line. All the points on that line will work. So I can make a solid line. If that was not equal to, I would make it a dotted line. It's sort of like an open circle in 2D. I make it dotted. You have to put a bunch of little circles. Just put a dotted line. So this is going to be a solid line. Kind of relates to this idea. Now, which side do I shade? Yeah, so let me show you 2 ways. Let me stop right there. Everybody should be able to graph that line. If you cannot do this section. You need to come see me so we can get you up to par with graphing lines. You have to be able to graph a line. So graph the line first. And now here's the textbook method. Use a test point. So one side is all answers, and the other side is all not answers, right? It's like Giants fans, Jets fans. So if I use the point 0, 0, that's what we almost always use. If I plug 0, 0 in and it works, then that side must be all the answers. Because every single point on one side or the other is an answer or it's not an answer. So if I find one that works, it's got to be everything on that side works. If it doesn't work, then nothing on that side works. So if I plug 0, 0 in, is 0 bigger than or equal to 0 plus 3? Is 0 bigger than or equal to 3? Hell no. So I don't shade this way, because that didn't work. I shade this way. So what that means is, whatever that point is, it would work in this inequality. Whatever that point is, it would not work. Right? So if this was an equation that represented an elevator's load, this would be a bad place to be. I would die, so I want to be up here. That would tell me the safe area to be. All right, you guys try this one. So graph the solution for this. And if you've learned this before and your teacher had a different way that they showed you, use that way. Just make sure you show me enough that I can figure out what the hell you're doing. that would involve plotting it on a graphing calculator, then screw that. Let's try a different way.
So if we don't do a test point, does it work down?
No. I want to hold off on the other way to do it. Because it gets weird when it gets really steep. It's hard to tell what's up, what's down. So I'm with you. I do it that way. So I want to do this one first, and then I'll tell you the other way. Cool.
It's gonna be the test.
Oh, yeah. He's going to be on the test. Thank God you got a whole weekend to do the homework. You're in college. You're not supposed to have a social life.
It's all of chapter 3 and chapter 4 that's gonna be on the
Yeah,
test?
all of chapter 3, all of chapter 4.
Okay.
Exactly. All right, so let me catch it. This is a you got it or you don't moment. Where do I start? What's the y-intercept?
4.
Cool, 0, 4. And then the slope tells me to go down 2 over 1. Good, not back 1. What kind of line is it going to be? Solid. So I like it. One of my old students, he said, if you see a line here, you graph a line there. If you don't see a line there, you make it dotted, right? So whatever sticks in your brain. So there you make it a solid line, because that means that every point on this line works in this inequality because it's allowed to equal that line. So let me go ahead and show you the two methods. The first method is the one we already did, the test point. Can I use 0, 0? Yes. So what's the only time I could not use 0, 0 to test a side? If the line goes through 0, 0, I can't use it. I got to use a point on one side or the other. And then I would use 1, 0 or something else with 0 in it to make it easy, right? So I put 0, 0 in. I get, is 0 less than or equal to 0 plus 4? Is 0 less than or equal to 4? I love my guys are like, no, I said, of course, yes, 0 is less than 4, so that's fine. So which way do I want to shade? Yeah, that worked, so I want to shade this way. The other way to do it, the way that I do it, I don't do it that way. It sounds like at least one person here doesn't do it that way. Watch this. Where are the y's smaller than that line? So where are the y's smaller than that y? Below it. So if I see less than, I'm going to shade down. If I see greater than, I'm going to shade up. But the steeper it gets, up and down are really weird sometimes. Right? There's still an up and there's still a down, because it's always going to be tilted one side or the other, unless it's a special case. So if you don't like that, you can use a test point. That's the way the book uses. Or you can just realize if it's less than, just shade down. All right, maybe. All right, so look here. Let's do this. How much time I got? I got plenty of time. Sweet. All right, so do number 2 here. Where are you at, Jeff? There it is. This is page 72. This might have something to do with this problem. If you wanted to, another way to graph a line is to get the intercepts. This one actually is really nice and easy to get the intercepts. Or you can always solve for y and get the slope and the y-intercept Either way, I don't care. I'm not going to tell you a specific way to graph the line. You do it whatever way you like better. Alright, so let me catch up to you. So you can either solve for y. If you solve for y, subtract 3x, divide by 4, so you get negative 3/4 x plus 3. Bless you. So hopefully if you solve for y, you got that. Then you can see the slope and the y-intercept. So if we did that, now watch. Y-intercept is 0, 3. The slope is down 3 over 4. But see, that's exactly, I got 0, 3, and 4, 0 for the x-intercept there, right? You guys with me? So I don't care which way you do it. Both ways kind of get the same line, so it doesn't matter. What kind of line is it going to be? Dotted. Why? You're not allowed to equal the line. So instead of using little open circles, we just do a dotted line to show that it doesn't, the points on the line don't work in that equation. So here's the, oh Jeff, you try so hard. Okay. So real quick, what I just said, if you do plug 4, 0 in, you get 12 plus 0 less than 12. Is 12 less than 12? 12 is not less than 12. Too bad. So whatever your restaurant it is, you can't eat off of that menu. So that's why it's dotted, to show that all the points in the line don't work. But one side or the other does work. So if I use a test point, I plug a 0, 0 in, I get 0 plus 0 less than 12. Is that true? Yes, 0 is less than 12. So this worked, so all the points on this side work. Or you just say, this you got to be careful. To use the other way, you got to solve for y. So if you want to use the quick way, you must solve for y. Where are the y's smaller than that line? Below the line. Kick ass. All right. So if you can graph lines, this should not be a big deal. It's just one extra step. Plug a point in and see if it works or if it doesn't work. That's the only new step.
Is it always true though that less than the shading will be below?
If you solve for y first. You with me?
So you can't assume that if it's less than sign.
Yeah, I couldn't know from the beginning that this is going to end up going down until I solve for y, because I might divide by negative and it flips.
Oh, okay.
Yes, good. So if you want to use a shortcut, you must solve for y.
Okay.
If you don't want to solve for y, you can't use a shortcut. You got to use the test point. All right. And again, this is a shortcut I showed you. The idea of, so you don't have to do the shortcut. Hell no. The book doesn't. I don't think the book talks about the shortcut at all. So you can just use a test point if you want to stay safe. So now watch. Here's the ultimate, the level, the next level, and thank God that's it. There's no other level above this. How do I solve a system of equations? What do I do with a system of equations? What do I do to solve it? How do I solve it graphically? A system of equations. X plus y equals 7. x minus y equals 2. What do I do with those things? Yeah, I graph them, and then I find where they meet, right? Is that cool? So here we graphed one line and shaded, so I could have a system of linear inequalities. I could have two of these bad boys, and then I just graph them on the same damn thing. The answer now is not going to be just where the lines meet. The answer is going to be where the shading meets. So it's going to be a whole little region, right? So if you can do this, you can do it twice on the same graph. Not a big deal. Let's see if that's true what I just said. So for example here. No, not there. Oh, and before I forget, just to remind you guys, in the blue book, they do have reviews for every chapter with answers. And I know I gave you a practice test. I'm going to give you an answer key, but if you wanted even more practice, they built it in, right? They're good like that. So here, let's try this yummy looking thing. Yeah, go ahead and do number 2 and 3. Call me over if you need some help. Do 2 and 3. There's one little weirdness with 3. I want to see if you guys are able to handle it. Yeah. No, it totally does, yeah. No, I did that. Let me see. Just go here when you divide by 4, you divide everything by 4. So then you can start here, go down 3/4, and you get the same. Either way. Cool. So that'll still, definitely, it's always a valid way to do it. Good. I like it. Yeah, good. Because then that way, yeah, exactly. So you did the first one completely right, and now just on top of that, the y-intercept, you count the slope, and you do it all the way. The answer, you just make it darker where the shading overlaps. because that area will be the answer.
That you can do with color, right? That's
Ooh.
Yeah.
See, I always say I would hate to have me as a student because look how messy I am. Plus, as a student, I always try to do everything as fast as I could. So I always had the smallest amount of paper when I turned my homework in, since I drove my instructors crazy. It's too bad for them. Everybody else had like stacks. Trust me, once you get to math 687, your homework is like this, stacks. Mine was always, eep. Right, I'm like, there's no way I'm going to write that much. Dear God, I don't like writing a lot. All right, so let me catch up to you guys. If you solve the first one for y, there it is. If you solve the second for y, you get that, I believe. Does that look right? Y less than, yes. 2 if it's x minus 2, yep. I like it. So if you did solve for y, that's what you should have gotten. So this first one, I highly recommend that you completely finish one and then you put on top of that the other one. Because otherwise it gets kind of weird as which line is which and what am I testing and holy shit. So this guy, y-intercept is 3. Tells me to go down 3 over 2. And what kind of line is it going to be? Dotted. Alright, that's close enough, Jeff. You did fine, Jeff. All right. And then the other guy, the y-intercept is negative 2. Go up 2 over 5. It is also going to be dotted. Wow. Now, what did you just do, Jeff? You just went against what you said. It's too bad for me. So before I graphed that one, I should have looked at this guy. And if you do the shortcut, less than, I'm going to shade this below. If you do the test point, plug in 0, 0, is 0 less than 0 plus 3, is 0 less than 3? Yes, so you would shade in the direction of 0, 0 because it worked. Now the other one says less than, so I would shade below it. Or if you use the test point again, you would shade the 0 less than negative 2? No, so you would shade away from 0, 0. That wouldn't work in the second line, so you would shade on the other side. One whole side works, or it doesn't work. So the answer is going to be that, because that's where the shading overlaps. So what can you tell me about that point right there? What's true about that point? Doesn't work in either one of those, right? Yes, sir.
For 2/5 x, why is it not negative 2/5?
Oh, okay. So if you subtract 2x from both sides, you get here, right? Okay, gotcha. Then the negatives will eventually cancel. Yeah. All right. So as long as you can do a single line by itself, you should be able to do this, which is just take another line and put it on top of that bad boy. And a lot of times what I have people do, if you don't like all the mess, you could just, when you do something, you just put an arrow saying that way and then put another arrow saying that way, so then you know at the end you would shade that piece in. So you just put arrows, don't put all the shading so that you're not making some crazy, something that looks like Jeff's mess here. Just put a little arrow and a little arrow and you go, oh, this is where they both arrows meet, is right there. I can't read you guys for shit. So what about this guy? The first one should be pretty simple, hopefully. What's the y-intercept of the first guy? 0. And then it says to go up 2 over 1. And what kind of line is it going to be? Solid. Kick ass. And then which way am I going to shade? It's less than or equal to, so it'd be down. Could I use 0, 0 as a test point?
No.
No, so I could use like 0, 1. So if we use 0, 1, is 1 less than or equal to 2 times 0? Is 1 less than or equal to 0? No, so I don't shade in the direction of that point, so I shade this way. Let me do it the way I just said. Arrow, arrow, there. So it's not so crazy. What about this weird dude? The hell, man? So how do I know this is a special case? There's no x. So what does a y equals? Oh, look at me. What's y equals look like? Yeah, like a straight line. this way, a horizontal line. X equals would be this way. So y, if I wanted to draw the line y equals -2, it would be at -2. But what kind of line does it need to be? Dotted. So at -2, I would make a dotted line. And watch how easy it is. When it's a special case, it's easy. Greater than would be shading up. Yeah. So what region do the arrows agree on? Let's say this is like 1, 2, 3, 4. There's 4 regions. Do you see that? What region do they agree on? 1, 2, 3, or 4? Shoot. Yeah, see this one's going this way. So it's got to be either this or this, and this one's going that way, so this is where the answer is going to be. That's where both arrows force me to go. See what shade in there. I'm sorry. So I was like, dude, man. Come on. Crank it down. All right. All right. That's all I got. I understand. Great, people. So I have an answer key for that practice test Tuesday. And then the test is Wednesday.
I have a question.